On Monday, we learned the significance of the zero product property and how it helps us solve these quadratic equations. So anytime you see a exponent 2 in any one of these equations, you're going to want to set one side equal to 0. You guys are used to putting variables on one side of the equation, putting constants or any numbers on the other side of the equation, and solving for a single variable. But with a quadratic equation, we're going to attempt to factor to solve. So I'm going to do one problem on the left, solve it. You can pause the video, attempt the one on the right before I go ahead and do the same example a second time. 6n squared equals 15n. Like I said, we want to set one side equal to 0. I'm going to do that by subtracting 15n on both sides. I have a new equation. 6n squared minus 15n equals 0. So what kind of factoring would I have to do to continue to solve this? There's only two terms. All I can do here is look for a GCF. I can at least start by doing that. So 6 and 15 have a common factor of 3. N squared and n, I can factor out n from each of those terms. That leaves me with 2n. 3n factored out of negative 15n leaves me with a minus 5 equal to 0. So when we learned the other day, both 3n could equal 0 or 2n minus 5 could equal 0. So I need to set up those two equations. So for the first one, 3n equals 0, I divide 3 on both sides and have one of my answers, which is n equals 0. You'll find that one comes up a fair amount in these problems. 2n minus 5 equals 0, so I'll add 5 to both sides, divide by 2. So I have two answers for this problem. N equals 0 and n equals 5/2. If you want to circle your answers just like that, that is fine. So if you want to pause and try this one on your own, 4n squared equals 14n, go ahead and do that now. And once you've clicked play, I will go over the answer. Remember, on this right side, when you subtract 14n from 14n, you get 0. That is the point of doing this problem. Once again, looking for a common factor. 4 and 14, I can factor out 2. N squared and n, I can factor out n. 2n out of 4n squared leaves me with 2n. 2n out of negative 14n leaves me with minus 7. So 2n could equal 0. 2n minus 7 could equal 0. Divide by 2 on both sides. 0 divided by anything is 0. Add 7 to both sides and divide by 2. Two answers, 0 and 7/2. Okay. A different kind of factoring. Let's look at y squared plus 12y plus 32 equals 0. You have learned this style of factoring, so it will require some retention from previous lessons on factoring. When you have a y squared term followed by a y term followed by a constant, we're going to attempt to factor this into two binomials. So remember, we're looking for factors of 32 that sum to 12. I see that I have positive signs in both cases, which I know means there's going to be plus. So if you're thinking about it, factors of 32 that sum to 12, that's going to be 8 and 4. So it's y plus 8 and y plus 4. Now this is a problem that we did on Monday where you have two binomials set equal to 0. We're going to say that both of them could equal 0 because of the zero product property. Solve for each of them by subtracting. So even though there's all positives in your initial problem, both your answers are negative. Negative 8 and negative 4. I'm going to move to the right. Hit pause if you want to try this one on your own. All right, you've hit play. Let's look for factors of negative 16 that sum to 6. So there's got to be one negative involved here. The bigger number is going to be positive. Factors of 16, this one's going to be positive 8 and negative 2. So x plus 8, x minus 2, equals 0. Same process as on the left. Subtract 8 from both sides. Add 2 to both sides. So this one gives a positive and a negative answer. Negative 8, positive 2. All right, last example style. Still got 3 terms, but I don't have an equation set equal to 0. I'm going to focus on the left first. X squared plus 3x equals 18. We said that getting one side of the equation equal to 0 is our friend. We want to do that. So what I'm going to begin by is subtracting 18 on both sides of this equation. I'm going to move it to the left side. That looks like something I can factor. I'm going to look for factors of negative 18. That's sum to 3. There's not that many factors of 18. You can come up with this. Positive 6 and negative 3. Subtract 6 on both sides. Add 3 on both sides. Once you've seen the pattern a couple times, it should latch on. All right, hit pause one more time. And let's go here. Once again, the 28 is going to get subtracted on both sides. New equation set equal to 0. Factors of negative 28. That's sum to negative 3. I'm thinking 7 and 4. The 7 is a negative. Add 7 on both sides. Subtract 4 from both sides. And you're done. So, a lot of work here, many examples. Hopefully that'll help you get through this lesson on solving quadratic equations.